All right, so for question 6, so let me just recount the history of this question. So we've already solved part A. So Henry was I guess let's say Henry's the first to solve part A with 28 questions. Yeah. And then Gregory managed to get part B with 20 questions. Okay. All right. And for a long time we couldn't get part C, okay? But the first progress I would say was due to, remember Edgar? He came up with a solution that did it in 18 questions. Okay. But then we kind of refined his solution to get it in like eventually to 13 questions. Okay. And so I guess I want to review Edgar's solution attempt. And even after getting it to 13, there was actually the feeling you could even get it probably further. There was more things to be done. Okay. So I kind of want to take us in this direction. Okay. And then maybe I'll tell you what the fundamental theorem of tournament towns is. Okay, so this was basically the construction, okay? So the refined construction. We take a rectangle to represent the 60 cards, right? And we use 2 questions to ask about 34 of them. Yeah. Okay. And then we take 1 question to ask about 17 of them. And then now we don't have enough cards to keep going unless we overlap, right? So start a new block. And 34 is already asked about from here. And then these 9 cards here, we overlap with 8 cards here. Yeah. Okay, so this is the refined version. So there's 8 cards here. Yeah. So this is 1 question. Yeah. And then there's 18 cards left here. Okay. So basically, the first 3 questions, if you let S be the total, yeah? Total of 60 cards. So all 60 cards. Then the first 3 questions gives you S minus the first 9 cards, yeah? That makes sense? You minus the first 9 cards. And then when you get up to here, 8, you get 17 of the 18. You can like omit the first card, right? So if you ask 1 question here, you can get 2S minus the first card, right? Does that make sense? Okay. So you can actually do it you can omit any card you want in the first 18. So you can actually do it 9 times, okay? So you do 9 questions here, where they're always minusing like the next card, yeah? And you get 2S minus the 9th card, okay? Do you understand what's going on? Are you paying attention? You try with all your might. Okay, so what happens if you add all these up?
17s.
Yeah, so if you add this thing up here, right? There's 9 things, so there's 18 S's. And then these are all minusing, right? -1, -2, minus the 9th card.
Yeah, this looks familiar.
Yeah. And then now you can cancel these by subtracting, okay? So this cancels with this, and you lose one of the S's to get 17S, right? That makes sense? Okay, how many questions is that?
13.
Yeah, so it's
12.
12.
13. No, 13.
13. So it's 3 here, 1, 2, 3, 4, and then 9. So it's 13, right? Okay. Okay, so then the question is, so the key idea here is you're kind of like, you got, you got like, you got 1 plus 17 here, right? So you got like 2s minus 1 and 2s minus 9. And so you're minusing the minus 1 from the 9 times. Yeah? Okay. But can you think of another way you might apply this idea? It may or may not be better, but can you think of another way to apply this idea? So that's my question to you.
Instead of 17 and 9 then, can you do 12, 14?
12, 14? You mean 12, 14?
Instead of partitioning it into 9 and 17, can you do 12 and 14? Does that work?
12 and 14. Wait, what, I'm still not sure what you're trying to say. So instead of doing this 9
Yeah.
and 17,
Yeah.
can you do what?
12 and 14.
Okay, so the 12 would go with some other questions here.
Yeah.
And then the 14 would go with 3 questions here.
Yeah, No, that does worse.
Oh. There's something simple, guys. So we're minusing 1 from 9 times, yeah? What else could we do?
3.
Yeah. So you could minus 3 from 9 3 times, right? So the problem is you might take a while to get to the 3, but you save 6 moves when you're minusing, right? So if we try to get to the 3, so if we get to here, so here's like another 34, right? And then there's like another 16, okay, from the 1, right? And then 25 off, and then there's 10 left here, right? Okay, and then what happens is there's another 34. Okay.
7. Hold up, did we just... No, never mind.
And then we have 7. Okay. 19. And then 19, which leaves 17 and 2, yeah?
No, we're not making it.
Okay, so basically, every 2 blocks of 60, we get 1 more here, right? So we need to get to the 6th block to get to 3, yeah? Okay. But here, we take like 1 move, 2 moves, 3 moves. It takes 4 moves to get to the -2, yeah? And so we kind of just make it. So what happens? You just make it with 6 moves to -3. Okay? Does that make sense? So what that means is, if you just make it with 6 moves to -3, then it'll still be 13 moves. Yeah. Okay, so you haven't dropped a move. Yeah. Okay, so that was like the first idea I had. Okay. 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 What was the second idea I had? So having done this, what could be like the next idea you have? I'll give you 3 minutes and I'll give you a hint.
Question.
Yeah.
How do we get like at the bottom, like we get like the 2s minus 1, 2s minus 2?
Yeah.
Like the s. Like,
Yeah.
how do we get that?
How do you get that? Okay, so if you take the questions, so like this question gives you this 34, right?
Yeah.
And this 34, yeah. This question gives you this 17, and this question gives you this 8 and this 9, right?
Yeah.
So if you ask one more question, then you get everything in the 2S except for one card. You see that? Because there's 18 cards left here. That makes sense. And so then we choose one of the cards to be 1, and we just change that one card every time. So this costs a question every time. Like all these others we don't change because they're always telling us about the same card. 102 cards. And then here we just keep asking 17 and omitting 1. You know? So we use 9 questions here. But when we give up on this idea, we only use 1 question to get past this, but not 9. You know?
Engulfed in darkness.
Yeah, so let me just draw this again. Okay, I guess a hint I can give you guys, if you want the hint, is that like while we're getting to 3, right? We actually got a lot of interesting things along the way. Okay. So 3 doesn't work, right? But we kind of picked up a lot of interesting things along the way. So I'll tell you what I mean by that in 4 minutes.
Wait, that's the same thing.
Intelligence at its finest.
Wait, is that the same thing?
trying to get 3 to go from 3, 3, 3, 3, 3, 9 to 9. It didn't reduce the number of problems, but it led us to something else. Okay.
Wait, how do we get the S minus 1 plus 2 thing?
This one?
Yeah.
Oh, because the first 3 questions only asked about 51 cards, right?
Yeah.
So that gives you S minus the first 9 cards. So we just wrote the 51 cards as S minus 9 cards.
This question was designed to make us feel pain.
This is a very nice question. Like, it involves pretty much only problem solving. You don't need to know anything. Maybe a little bit of algebra, but that only hurts you.
My point stands, it causes you pain.
In a different sense.
I think people misassign the source of pain. Like, it's literally your own body that's creating the pain, right?
Wait, question?
It's just like ignores me.
Like, yeah.
Yeah.
So what if, like, so you know how we have to get like the 9 questions?
I thought he was gonna be like, question, card 1, card 2, card 3, card. What's your question?
So you know how like our aim is to like find like the 9 cards?
Yeah.
Yeah, what if we like don't do multiples? Like what if we like add like another layer of complexity? So like in a sense, you essentially just like divide it in such a way like 9 for example into 2 and 4, or like 4 and 4. So you have 1 card left and then you find another way to find that 1 card.
Yeah, so he's not wrong. Okay, so this is a good idea. So if I take your idea all the way to the end, okay, you will save questions. Okay. I guess there are simpler ideas though that are special cases of that idea. Okay. So the one that I'm thinking of is, okay. So look at this. So I drew all these numbers to get to 3, right? I didn't even get to 3, but I would have got to 3 in the next one. Yeah. But I drew this because it's all here. Okay. And the point of drawing 3 was to get 3 3s to minus from 9, right? Okay. But look what I have here. I have stuff like 10
Yeah.
and 2, yeah? You see?
Yeah.
You see why 10 and 2 could be helpful?
Yeah,
because 5 2s come from 9, from 10, right? If you minus 5 2s from 10, that's the same as minusing 9 1s from 9, right? So maybe can you guys execute on that idea and see what happens? Do you understand what I'm saying?
1, 2, 3, 4, 5, 6.
So do you understand what I'm saying here?
Okay,
You're a few problems short if you do that. That's what I'm assuming.
Okay, don't assume, explicitly see what happens.
Yeah, you're probably short of questions.
Do you understand what we're trying to do? So we're applying the same idea of 3 times 3 equals 9 to 2 times 5 equals 10. Okay. Alright, does Max and Andy know what we're doing?
Yeah, mostly.
Alright, good. Okay, I'll show you what it is in a few minutes, but I want everyone to try themselves first.
Question mark solution.
Question mark solution.
Okay. Did you get it?
Sebastian thinks he may have a solution.
I think it's no, it's probably a 14.
Okay, so if you look at these questions, okay, so let's just say here you ask, there's one question here, two questions here, one question here, one question for the 9 and the 8, yeah? One question for this 17, and then one question for this 1 and the 16, yeah? Okay. What that gives you, okay, is 1, 2, 3, 4, 5, 6 questions,
Yes.
and it gives you 3S minus the first 10 cards, right?
Yes.
That makes sense? Because each one of this is S. So we got 3 lots of S, but we don't have the first 10 cards, so we have 3S minus 10 cards, yeah? Make sense? Okay, now we go further, so now we put this 10 with that 7, and we get a question, right?
Yes.
And now we have 19 at the front, right? So 19 means we can ask about 17 and leave 2 out, right?
Yeah.
So we can just leave out the first 2, then 3, 4, then 4, 5, 6, and then we can leave out 5 groups of 2s, right? So in 5 questions here, okay, we can leave out, so these 5 questions leave out, I guess, plus these 3 extra. So they essentially give you, so there's 4 S's, right? There's 4 blocks, yeah? Desmond, you need some sugar or something?
Yes. I haven't. If you didn't have full lunch, because I had to go this for more music.
Oh, you should tell me. I have stuff.
Do you have sugar?
I have.
No.
Okay, so what this gives you, right, is it gives you 4 blocks of 60, right? So 4S, yeah? And you're minusing 2 cards from the front, so it's minus 1 plus 2, right?
Yes.
Okay, but you do this 5 times, and you keep switching which cards you're minusing. So you minus the next 2 cards.
So are you claiming we can do it in 11?
No.
Let's see. What does this add up to? 5 plus 6, and then it's 7 plus 8. See, it's all, and then there's 4S minus 9 plus 10, right?
should solve it. If we're not being scammed. If,
How does that?
So if we add these up, right, we get 20s minus the cards from 1 to 10, right?
they add up to 17s again.
Okay. So then we subtract these two, right? And we get 17s. You see? That makes sense?
I don't feel like there's anything wrong with this.
So how many questions did that take though, okay?
11.
So 1, 2, 3, 4, 5,
Right. Yeah,
6,
12.
7. 7 plus 5, 12 questions, right? Okay, so it doesn't, solve the problem, but hey, we just shaved the question, right? So that should be promising, yeah? So that could be like, hey, this idea is actually, we're getting reward for exploring the idea further, right? Okay.
Wait, why is 20 minus 1 to 10 17s?
Now these two things, so we're subtracting those two things.
Oh,
So we know these expressions. So when you subtract it, this cancels with that. And 20 minus 3 is 17.
no, we can't. Okay.
No.
We can't.
Does that make sense?
That's
Okay.
crazy.
So just to keep it like a bit easier for you, like what the point I'm gonna try to make is it's in front of you somewhere, okay? So what other ways can we use this idea? And it's all in front of you.
Really?
Okay? It's all in front of you.
1, 2. Then we quoted that. Right.
Okay, so now we're down to 12 questions, okay?
I think I have a solution in 9 questions.
Oh.
I think.
Locked.
Maybe.
He's locked.
Wait, let me explain it to this guy first.
How?
Slave to this guy.
Okay,
He needs
so-
activation.
You start with these two.
You're loud enough that you're already explaining it to everyone else.
Oh,
Okay.
yeah, that's fair. We do these two. And then
Just in case if you spoil the question,
okay, so you start with actually doing all the questions except C1. So you do 2s minus C1.
What?
I think. Yeah, because 17 times 7 is 119.
Oh, okay.
So you miss exactly one card, which is C1.
Yes.
So you get 2s minus 1.
Alright guys, I guess I'm kind of still, like everyone else should still be kind of figuring out what I'm asking, yeah?
Oh, what else?
You get this question and this question. So this you get 7 questions and then 8, 9. And you figure out
So that happened to 13. Wait, so what do you do? So, okay, so you found all of them except C1, right? Is the C1? That's C1, that's the. Okay.
So
So
you
how
can-
many is this? How many cards is this? 51.
Yeah.
Oh, and then, okay.
Alright, does anyone see anything they can do to improve? On the same idea, but instead of 2 and 10, can we try to do something else?
1 and 9 seems a bit weird. Yeah.
The 1 and 9's done,
Your
okay?
first 7 questions.
We've essentially
are
already tried
1,
that.
2, 3, 3, 4, 5.
We tried
6,
2 and
7.
10.
Right.
Yeah.
What are you finding?
3 and 9
So then
takes
you
too
leave
many,
this,
right?
you get 2 and
3 and 9 takes
Yes.
13. Yeah.
Yeah.
What else can we do?
This looks good right now. What else?
So I guess I can.
So we could subtract this.
How do you get this? That's my question.
So you can take like 5 from 10, okay? But that takes a while,
3, right?
and it's not on the screen anymore,
This and
okay?
this.
So
Yeah.
If
is that
it's-
already a question we can get?
if it takes,
No.
No. How do
it'll
you
take too long to get to
the
5, yeah.
1, 2?
Okay, so
We petitioned 190.
my clue to you is the idea I'm looking for is entirely on the screen, okay?
17.
Yeah.
I think 119.
Yeah.
And then after that,
I can't hear Lawrence. What did you say?
we do. So those 7 cards. 8, 9.
I can't hear you.
Yeah.
Okay, I'll give you a little bit more time. But the idea is on the screen, okay?
You know this.
So notice we're not necessarily getting the perfect version of the idea. We might be able to clean it up, but we're not saying to clean it up. We're trying to find another idea.
This one card we just see
Okay.
one piece, 17.
So your first 5 questions are 1, 2, 3, 4, 1, 2, 3, 4, 5, right? And then you want to. How do you distribute these? Can't question 6 just be this, and question 7 be this, and you still get the sum 190, but you get these 2 questions for free.
I did not think of that. I might be stupid.
Wait,
That would be
does
7.
this solve this question in 7? Did we prove that was impossible? Or
But
did
then
we-
it's algebra. We get algebra.
Oh, yeah. Where are you getting these from?
I petitioned about that.
There's got to be some kind of tutorial somehow, I think. I guess.
But how will we algebra this? No, this solution can't work. No, this won't work unless I can figure out 1, 2, 3, 4, 5, 6, 7, 8, 9.
I'll give you 3 more minutes, okay?
Yeah, what? Probably won't work. And then we forget, if it works in 7, you get 3 extra cards. Or 3 extra questions that you can use.
So if the app is all up, you get. Okay.
So you get a duplicate of 1.
Yeah. So
This 2 is the same as this 2.
let's just do how do we get this? Oh, right. This, right.
Yeah, 13, 4, 13, 4.
This. So what do you think about this then?
S minus.
Because these already counts for this first question.
Oh, does this work? Please don't tell me this works.
It probably won't work because then you get two
Alright.
S.
Yeah, you get
card 1, 2, 3,
Okay,
4, 5, 6,
so
7,
the reason
8.
why I don't think this works,
Yeah, definitely.
because then you can't just answer it.
Alright, so
Unless we used that method before, but then where'd you get the 8 from?
The problem.
Unless we did another partition, another separate.
alright, did anyone figure out where the other method was on the screen? So we
1
had
and 2, I think.
okay, so we can't do 1 and 2, and we can't do like so we can't go that way, if that makes sense. 'Cause, like the 2 is made from this one in some sense. Like
Yeah, we just do.
yeah, it doesn't quite work backwards. Oh, 2 and 1. Yeah, it doesn't quite work backwards because what happens is instead of getting 17s, you get 0s. So the s's cancel. So here it's like this is 2s minus 1, right? And then you get 4s minus 2. And here you get 4s minus 2, and then the 4s's cancel. So you can't do it the other way, yeah? Okay. But actually there are two numbers in front of you for which this actually does something pretty helpful. Oh, what? This guy has snuck in his answer just in the nick of time. So 8 is also a multiple of 2, right? Does that make sense? So 8 is a multiple of 2, and what you get here is you have like s plus like 8, right? Yeah. And here we get 4s minus 2, right? So if you do that sort of, if you do this 4 times, you get 16s minus 8. And then when you add these together, you get 17s, okay? So if that was to happen, right, then that would happen in one less question, right? Does that make sense? Okay. Okay, so it'd be 11 questions, right? Okay, but the question is, like, and also, you know, like 11 is very close to 10, okay? So here you might not be looking for a completely new idea. Maybe you just try to clean up this idea, yeah? So there's at least 2 things about this idea that could be cleaned up, okay? What are they?
I think you could
I'll
shave
give you
off
some time.
one question.
Shave off one question.
One.
Andy with the instant response.
I just realized.
How do you shave off one question?
Auto check.
Okay, so just reverse the 8 and the 17 and the second, and the
Swap the 8 with the 17.
yeah, swap the 8 with the 17. It does nothing like
Oh.
it does nothing generally, but you already answered the 17.
Okay, so you swap this 8 with this 17, yeah?
Yep. And that 17 has already been answered by the first set, so you don't need the extra question to answer the 17.
Okay.
Could the 8 like so
No,
10.
you don't need the extra question because that's already answered by.
Yeah.
Uh,
So,
you-
so Andy's idea is basically smack in the middle of the 2 things we're trying to do, okay? But it's only one thing, okay? But it intersects with both things.
Kill 2
Okay.
birds with 1 stone.
So it's not killing 2 birds with 1 stone. It's really
You warn both birds before you kill them.
it's having 1 stone and
Or
you
you
want
can-
2 stones, and the 2 stones are not independent of each other. Okay.
Mutually exclusive.
The birds are tied together on a string.
Yeah. Okay, so this is both. It introduces an idea that can help us solve the problem, but it also introduces a problem. Okay.
Duplicates.
But the problem it introduced,
Solve the problem.
it kind of already existed. Okay, because before what you had was when the 8 was over here, right? It didn't overlap with the 2. Well, I guess it did, but not. No, actually, it didn't. It didn't overlap with the 2. Okay, but now it's moved. It overlaps with the 2 now, right?
Yeah.
But the problem here is the 8 and the 9 are asking about the same cards. Okay, see? The questions have to ask about different cards.
That sucks.
Okay.
Oh, yeah.
Yeah, but just because it doesn't work immediately doesn't mean it's worthless. Okay. So he somehow managed to, like, there was 2 things you could have said, and you said sort of half of each. Okay. He didn't say one or the other.
0.5 versus 0.5. I mean, since since the 34 encompasses 2 of the 17 questions, why don't you just move both of like the 8 and 17 blocks to like 34 is?
So you can move. So you want to move the 8 block or which block?
8 and 17. So like 17 is already past 134.
Okay. So. Okay, so you're saying to move the 8 block, this block. Is that what you're saying?
No, I think you meant like swap the 34 and the 17 around.
Yeah.
I mean,
Isn't
swapping.
that the same thing?
Oh yeah, that's the same thing.
3 times 17. What did Lauren say?
Okay, can I maybe focus your ideas? Our time's kind of running out. So we have a choice. We have basically the problem is the 9 and the 8 are overlapping, right? So the simplest way to try to solve this is to move one of them. Yeah. Okay. So you can either move the 8 or you move the 9. Okay. Yeah. Which one would you move? And then where would you move it?
Move the 9. Oh,
Okay, so 8 or 9, which one? And then why?
Move the 8, definitely.
Definitely. Instead of a reason, you made it more certain.
Yeah.
Instead of why, you doubled down.
Yeah. The only reason you need is your confidence.
This is one of the problems.
Sebastian's life choices.
That's literally private school culture, guys. Like, you don't need to know why. You just need to be more sure, or express more certainty.
For sure.
Ah,
more
yes,
kings.
more knocks. Okay. I'm not giving you a great reason, but I guess one of the reasons 8 just got moved. Okay, it got moved because it rather would be there. Okay, to move it back would just be like it's undoing the idea. Okay, but one of the good reasons the 8 is there is overlapping with the 2. Okay, that makes sense. Yes.
Yeah.
So this 2 is now overlapping with this 8. Because this 2 needs to minus from this plus 8. Yeah? They have to be the same cards. Yeah? So I would suggest moving the 9. Okay? So where can you move the 9?
Into the 17.
Okay, into the... It has to break the 17, right? I mean, it could break the 34, but let's break the 17, yeah? So what how do we move the 9?
We get S minus 1, 2, 3, 4, 5, 6, 7, 8. What?
Put 8 on
So
the
you see how we have this problem, right? After all the 7 questions,
Huh?
after the 7 questions, we got like 2 S minus
8 on the right and 9 on the
How
left.
we need to solve it.
Why? Why are we doing that?
We get this, right? So we get S minus 1, 2, 3, 4, 5, 6, 7, 8, 9.
9 on the left.
So we add 3 questions to answer these 51. So we get
Okay.
10 questions.
So the result of the algebra.
Yeah, it
I
needs
don't
to be
think
more
the
on the
algebra
left,
will
right?
work.
So it needs to be at least 9 on the
This is
left
2s, right? So if
to
you
not
want, we
intersect
get
with this 8, yeah?
4s minus
And then 8 on the right, is that what you're saying?
1.
1 minus 129, whatever. And then we use 2, yeah, and then we use this to get
2 S minus 1.
Alright.
the
Okay,
front
so-
one- no, the original, yeah, okay. So if
So-
you do this, then it goes back to 4, then it goes, if you subtract this twice, you get negative
Okay, so
339. Right.
Well, why would
there's a better choice than this, okay?
This.
So let's just say we're putting the 9 over here now, okay?
we just subtract it twice, but we
Okay, we're putting the 9 over here. And this number needs to be at least 9, okay?
minus 1 to 9.
Right?
We get S
Exactly
minus 1 to 9.
It has to be 9 or more because it can't intersect with this 8, right?
Wait, would this work?
Okay? But I'm saying this number could be better another number instead of 9.
You only need 34,000.
Okay? There's a better number to put.
So our solution is
So you literally have
3, 4,
like
5.
7 choices, yeah?
17.
17. Think about why you might like put like what difference does it make, you know?
What if you put 1?
Can we be cooking?
You can't put 1, remember? It has to be more than 9.
Other ones. So
Oh.
S, 2s minus.
Okay, you guys are paying attention to the wrong teacher, I guess.
Oh, yeah, more bad game.
15 and 3.
15 and 3. Why 15 and 3?
Not particular.
So basically I'm saying I want the number to go, so we basically picking, if you pick a number to go here, then we want this to be 9 and this one adds up to 17 with that. So it's just picking a number here, okay? The number has to be more than 9, okay? Because otherwise it'll intersect here. Okay, but 9 is not the best choice, okay? There's actually a good choice of number and I want you to find it and explain to me why. So you have like 3 minutes, okay?
Just a hunch, is it 10? Because, like, in the S or whatever, they already asked about, like, power, so.
Could it be more than just a hunch at this point? Like the hunch could give you the guess, but then after that,
Did I get it right?
well, yeah. But is it still a hunch?
Well, it's not a hunch when you said it.
Does 11
Okay,
work?
look what Lauren said. You make this 10, okay? Yes? Because part of the problem with this 9, well, the reason it got moved there in the first place was because you wanted to you want to save a question with this 17, right? Yeah? But now the 9 broke up to 17, so you have to ask an extra question here now, right? But look, if you do 10 and 7, this is the same as this question here. You see? Does that make sense? So 10 and 7 saves you this question here. You see? You looking? You understand?
Bruh,
And how many questions is it now?
1, 2, 3, 4, 5, 6.
10. Wait, this is
Hold up. Do we have to ask the question for the extra 17 at the end of the? Because we have at the final block we have 217, 734. Do we have to ask an extra 17?
No, that's part of the 4 questions.
Uh,
Because every one gives you a 17 too.
Oh yeah, this works.
is it 4 questions? Yeah.
Does everyone understand how this works?
Yeah.
So now you have, so when you go up to here, the first 4 questions, so we have 2 questions for the 34, 1 question for the 10-7, 1 question for the 17, another question for this 9-8. Actually, we don't have this 17 yet. So we have 1, 2, 3, 4 questions. And these 4 questions get us s plus 1 to 8. Yeah? That makes sense? Okay, then we keep going. Now we have the 5th question with this 17 here. And then the 6th question with this red 1 and 16. Wait. Am I counting them right? Yeah, but okay, so we have this 5, 6, but we don't count this question, okay? Because this one's already been asked. Yeah? So we're still at 6, and then we do 4 questions of the form 4s minus 1 plus 2. Yeah, times 4. And this will give us 16s minus 1 plus 2. Actually, it's not quite this, yeah? Can you see what's wrong? And then the cancel to get 17s. Okay, what's wrong with this so far? What's wrong with this?
The 2 still intersects with the 8.
Yeah, because it's 19, right? It has all 19.
You can avoid that, but...
Yeah, okay, so the issue here, so this is just finicky, but you should probably be able to spot it. This is not the first card anymore, it's the 2nd to 9th card, right? So this is actually not s plus 1 to 8, it's s 2 plus 8, 2 to 9, right? Yes? Yeah, and then here we just replace the 1 and the 2. We can do 2 and 3 and then get all the way up to, or like, we can do 2 and 9, yeah. Yeah? Does that make sense? Does that make sense?
Yeah.
And here we can plus the 9. Yeah? So that solves it, yeah? Okay, so I should point out some bloopers that I had. So the original solution I had, it might have been similar to Sebastian's actually. So basically what the original solution I came up with was I was trying to do like 7, 8 as 15 and then like minus 10, minus 2, minus 2, minus 1 or something like that. Yeah. Okay. But it's kind of too complicated. And actually, I presented it and it didn't work, and no one caught it. But the reason it didn't work was it kept asking this, like the cards kept, like the questions weren't defined properly. And the cards kept overlapping or not overlapping. You know what I mean? Okay. But I was actually very confident this approach would work for several reasons. It's not all of them mathematical, but but yeah, I was so confident that I ended up live solving this thing after not succeeding with the other one. Okay, so I just did it in front of the board. But the basic idea is like if an idea is good, it's kind of immune to little mistakes. That's one thing. Okay, you'll discover that at some point. It's like if you know something works, like it could maybe not work exactly right, but there's definitely a way to make it work. Okay, that's one of the beliefs I had. Another reason that I went that wasn't mathematical was kind of like the fundamental theorem of Tornham and Towns. We joke about this, but it's like basically you think it's impossible, but it's actually a construction. That's basically what the fundamental theorem is. It's like a joke. Okay. But if you think about it for this question, right? Like if we just looked at Gregory's idea, that would solve part B, right?
Yeah.
So what's the point of Edgar's idea then? You know? It's like, were they just not aware of that? Or like, so for Edgar's idea to really come into the question, it should get down to 10 somehow, right? And also, if you kind of looked at our proof for why 5 or 6 doesn't work, that's not a junior proof, okay? That's a very difficult proof to execute. Even if you found better ideas to improve on it, just the fact that it starts like that is pretty insane already, if that makes sense. So this is not a maths reason, but essentially, if you had to prove that it couldn't be done in 10, like the proof would seem very like crazy. Okay.
Yeah.
Whereas if you had a construction, that would like be very easy to write. Yeah. Okay. Does anyone have any questions about this? Okay, maybe I'll do a quick should I do a quick solution summary?
Sure.
Okay, maybe I can do it in better notation as well.
Just like having it all.
Oh no, not clear. I don't want clear. I'll do a solution summary and then we'll do a dinner. We'll go dinner break, okay?
Satisfaction.
But actually, this problem isn't done, okay? Remember, our problem is what is the smallest number of questions, okay? So at the moment, our answer is actually either 6, 7, 8, 9, or 10, okay?
I think Sebastian got it down to 7. I can't find it.
7.
You think he has a construction for 7 questions?
Yeah.
How come this was not brought up? You think you ask it in 7 questions? How?
Seems to work.
So, 2 blocks.
Wait. Oh,
2 blocks.
2 blocks. Yeah, good.
So you start at the very start with 34.
He seems so eager.
Oh, no,
Oh, you would be if you got to 7.
Okay, so you start with 34, and then you do 13 and 13.
So I had this. This was a good way to do it, so you didn't duplicate questions.
13 and 13.
Yes.
Yes.
So you're using the same 34 again.
Oh no,
No,
later.
on the
Just
same block as the 34.
let's just.
We fill a full 60 with 34, 13, 13, basically.
Yeah,
13, 13.
Yeah, and then you divide the second row into 1, 4, 4, and then 51.
1, 4,
One.
Other way to avoid
Oh yeah,
duplicates. Other way to avoid.
1, 4,
Yeah.
4,
And then
51.
yeah.
What?
Okay.
So then, how you solve it is you start by finding you start with 2 questions to solve the 34, 3 questions to solve the 51.
2 questions to solve 34. Yep.
That's not the way this works.
Okay.
And then 3 questions for the 51.
3 questions to the 51. Yep. Okay.
And then you do 2 questions. You do 13, 4, and then the other 13, 4. It doesn't matter. Both work.
Okay.
It's already 7, but you just have the first card.
Yeah, and that's it. That's all you. You only need
Oh,
those.
did I-
Doesn't solve anything, right?
13.
4. So that's one
Last card to
quote.
consider.
Yeah.
That one middle card.
13,
No,
4.
but it's already covered. That's the point.
And then what we do is
You get 2s minus 60 or something, yeah?
so we start with 2s minus cards.
2s
we're gonna
minus
call-
60.
Yeah, Sebastian's naming system was backwards. So
Yes. We get 2s minus 60. We also get the 2s minus 60, 59, 58, 57, 56.
Oh, by switching around the 4s? Is that what you mean?
Yeah.
Ew.
And then after that, so we get so with my numbering system, but I'll adapt it. We get oh no, we get a combination of what 2s minus. Wait, can I show you?
it's ignore the purple ones.
Alright, Sebastian here.
2s minus all the purple ones.
So my system is opposite way. Basically, what you do is we can find if this is 1, 2, 3, 4, 5, 6, 7, 8, 9. We find 2s minus 1, 6, 7, 8, 9, and 2s minus 1, 2, 3, 4, 5.
Minus 5 things. Minus 5 things. I'm confused about 5 things. Oh, so it's minus 1 thing. That I understand that.
It's because we can identify that. We can identify that.
What does that mean? Identify.
So we know what this is, so adding that and that, and we know what this is, adding that and that.
Yeah.
And then so do all adding
Can Andy explain it?
You probably explain it.
let's see. Is there a better way? So I think you do 2s minus all the purple ones plus and 60.
2s minus.
All the purple ones.
Wait,
Purple set plus 60. This,
wait, actually, that might be a.
I'm confused. So,
No, I want to.
huh?
yeah, okay.
Yeah, but then.
Yeah, no, that's gonna definitely lead to 0s actually.
0s.
Yeah, okay, so the ideal is to add up like 4, 4, and 1. Like, you can get
To get
4,
9.
4, 1 to get 9. You can get that 9 as s minus the 51.
Oh, but it's the same 9 though. That's the problem, I guess.
Wait, hang on. I feel like it's still 2s minus 1, and we get s minus 1 to 9. That should still work. I think.
Oh, so you're getting 2s minus 1 to 9. That's 9 questions, right?
No, that you can get that automatically. I think.
Oh, 2s minus just 1 to 9 from the 5 questions. Wait,
from
no.
7.
Yeah, just
From
from,
the
just from the 3 questions to 51.
That's just s minus 9.
Yeah, you get s minus. You get 2s minus.
To get 2s minus 9, you need to do this thing 9 times.
Yeah, no, okay. Put on paper.
Alright, so maybe you can try to twiddle it some more and then show me what you get, yeah?
Like 3 lessons.
But I guess it's finished. If this wasn't like a exam contest problem, it would be much harder. But you don't actually know if it's true or not. Like the question would be like, what is the minimum? We still don't know what the answer to that question is. What is the minimum number? All right, let's make a recording.